Hi everyone, I'm Dr. N.Senthil, Associate Professor, Computer Science Engineering. Great pleasure for me to welcome you all for learning this session. In this session, topic to be covered is technologies of distributed computing, part 2, and Unit 1, distributed and cloud computing. At the end of Unit 1, the students will be able to describe the core features of parallel and distributed computing in cloud. At the end of this session, the students will be able to understand the service-oriented computing technology. In this session, we will discuss about service-oriented computing, service-oriented architecture, web services, and web service interaction. Service-oriented computing organizes distributed systems in terms of services, which represent major abstraction for building systems. Service orientation expresses applications and software systems as an aggregation of services that are coordinated within service-oriented architecture. Even though there is no design technology for development of service-oriented software systems, web services are the de facto approach for developing SOA. Web services is the fundamental component enabling cloud computing systems that leverage the internet as the main interaction channel between users and systems. A service encapsulates a software component that provides a set of coherent and related functionalities that can be reused and integrated into bigger and more complex applications. The term service is a general abstraction that encompasses several different implementations using different technologies and protocols. The four major characteristics that identify a service are: boundaries are explicit, services are autonomous, services have schema, contract, not class or interface definitions, services compatibility is determined based on policy, service oriented architecture is an architecture style supporting service orientation. It organizes a software system into a collection of interacting services. Service-oriented architecture encompasses a set of design principles that structure the system development and provide means for integrating components into a coherent and decentralized system. Service-oriented architecture-based computing packages functionalities into a set of interoperable services which can be integrated into different software systems belonging to separate business domains. There are two major roles within SOA that are service provider and service consumer. The winning features of service-oriented architecture within an enterprise context are standardized service contract, loose coupling, abstraction, reusability, autonomy, lack of state, discoverability, and composability. Web services are the prominent technology for implementing service-oriented architecture system and applications. They leverage internet technologies and standards for building distributed systems. Several aspects make web services the technology of choice for SOA. First, they allow for interoperability across different platforms and programming languages. Second, they are based on well-known and vendor-independent standards, such as HTTP, SOAP, and WSTL. Third, they provide an intuitive and simple way to connect heterogeneous software systems, enabling quick composition of services in distributed environment. This diagram describes the common use case scenarios for web services. System architects develop a web service with their technology of choice and deploy it in compatible web or application servers. The service description document expressed by means of Web Service Definition Language (WSDL) can be either uploaded to a global registry or attached as a metadata to the service itself. Service consumers can look up and discover services in global catalogs using Universal Description Discovery and Integration (UDDI), or most likely directly retrieve the service metadata by interrogating the web service first. The web service description document allows service consumers to automatically generate claims for the given service and embed them in their existing application. Web services are now extremely popular, so findings exist for any mainstream programming language in the form of libraries or development support. This diagram shows the web service technology stack that lists all the components of the conceptual framework describing and enabling the web services abstraction. These technologies cover all the aspects that allow web services to operate in distributed environment, from the specific requirements for the networking to discovery of services. The backbone of all these technologies is XML, which is also one of the causes of web services popularity and ease of use. XML based languages are used to manage the low level interaction for web service method calls, that is simple object access protocol, for providing metadata about the services WSTL, for discovery services UDDI, and other core operations. In practice, the core components that enable web services are SOAP and WSTL. Summary of this session is: we learned about service-oriented computing and service-oriented architecture. I hope you found this lecture is more informative. Thank you and have a nice day.